Question 26. A camera films the motion of a swing in a park. Let x of t be the horizontal distance, in meters, from the camera to the seat of the swing at t seconds. The seat is released from rest at a horizontal distance of 11.2 meters from the camera. Part A. The rate of change of x can be modelled by the equation dx dt equals negative 1.5 pi times sine of 5 pi over 4t. Find an expression for x of t. The question is asking for an expression for x of t, which represents the horizontal displacement of the swing from the camera at time t seconds. Now what's given is an expression for dx dt, which represents the velocity of the swing at time t seconds. So in order to get x of t, we need to find the antiderivative of dx dt. In other words, the integral of negative 1.5 pi times sine of 5 pi over 4 times t. So x of t is equal to the integral of negative 1.5 pi times sine of 5 pi over 4 t dt. I'm going to take out 1.5 pi outside of the integral, just to make it a little bit easier. So x of t is equal to 1.5 pi times the integral of negative sine 5 pi over 4t dt. Now the integral of negative sine is cos. And if you recall, the derivative of sine is cos, the derivative of cos is negative sine, so the antiderivative of negative sine is cos. And that's why this expression here involves cos. So x of t is equal to 1.5 pi times cos of 5 pi over 4t divided by the derivative of what's inside the brackets. So the derivative of 5 pi over 4 with respect to t, that's why we divide by 5 pi over 4. And then we add the constant of integration c, which we'll need to find later on. So simplifying all of this, and the pi here will cancel with the pi here. And we have 1.5 divided by 5 pi over 4 as well. So we get x of t is equal to 1.2 cos of 5 pi over 4 times t, plus the constant of integration c. Now we know that at time t equals 0, the swing is 11.2 meters away from the camera. And we can use that fact, which is our boundary condition, to find the value of c. So x of 0 is equal to 11.2. In other words, 11.2 is equal to 1.2 times cos of 0 plus c. And cos of 0, of course, is 1. So 11.2 is equal to 1.2 plus c, hence c is equal to 10. Therefore, x of t is equal to 1.2 times cos of 5 pi over 4 times t plus 10. Part B. How many times does the swing reach the closest point to the camera during the first 10 seconds? The first thing to note is that the closest and furthest points of the swing from the camera are reached when dx dt is equal to 0. Now, dx dt represents the velocity of the swing at time t. Let's go back to the diagram. And if we can picture this swing going backwards and forwards, the velocity of this swing is 0 at the endpoints. So it's swinging, let's say, this way. Slows down, comes to a halt, stops momentarily, and then swings back the other way. Comes back to this point here, which is the point that's closest to the camera. The swing will stop, in other words, its velocity is 0, and then will swing back the other way, and so on. Now, at the endpoints, the velocity is 0. At this point here, which is the center of travel, the velocity is at its maximum, assuming a forward direction, of course. The velocity will be at its minimum if it's going in the reverse direction. So if we refer to it in terms of speed, the speed of the swing is maximum at the center of travel. The speed is 0 at the endpoints. So when we talk about velocity, we need to take into account the direction of travel. So if we're just thinking about the speed of the swing, like I said before, maximum here, minimum or 0 here and here. So let's go back to our solution. So the closest and furthest points are reached when the velocity or the speed is 0. We're only interested at this point here, not this point. This is the furthest point. We want the times when the swing is at its closest point. So as the swing is going backwards and forwards, half of those times when the velocity is 0, the swing's at its furthest point. The other half of those times, the swing is at its closest point. So we need to ascertain which half are we talking about here. So if we consider sine of theta, so I'm just replacing 5 pi over 4t with theta just to make the explanation a little simpler. We want the points where sine of theta is equal to 0. That's where the velocity or the speed is 0. And that occurs when theta is equal to 0, pi, 2 pi, 3 pi, if you visualize the graph of sine theta. And in this case, theta represents 5 pi over 4 times t. So we want to find the values of t that give us a value of theta, 0, pi, 2 pi, 3 pi, and so on. So we want to solve this equation here for these values of theta. We want to solve this for t. So solving 5 pi over 4 times t is equal to 0, pi, 2 pi, 3 pi, and so on. So dividing each of these values by 5 pi over 4, we get t is equal to 0, 0.8, 1.6, 2.4 seconds, and so on. Now at t equals 0, if we go back to the diagram, at t equals 0, the swing is at its furthest point. At t equals 0.8, the swing is at the closest point, and it'll oscillate in that manner. So we got furthest point, closest point, furthest point, closest point, and so on. So following that pattern, the closest points occur at 0.8 seconds, 2.4 seconds, 4 seconds. Notice that we're adding 1.6 seconds each time to get the next time. So we got 5.6 seconds, 7.2 seconds, 8.8 seconds, and 10.4 seconds, which exceeds 10 seconds. So we're going to discount this solution here. So counting these values here, we got 1, 2, 3, 4, 5, 6. Therefore, the closest point is reached 6 times in the first 10 seconds.